Hello, welcome to rational functions. Technically, it's part of still the rational unit, but I've separated it. I didn't put it on that test. Even if we were still meeting in person, I still wouldn't have put it with that rational test. It's kind of a unit or topic on its own. Now, I'll be honest with you, this is a tough lesson. It's not hard, but it's a totally new concept. So we're learning some new things and practicing some new things. So it's not hard, just new concepts. Even when we're together live, this lesson tends to not go well on a regular thing. Like I said, it's not hard, just new stuff. So usually when we do this, even if we're all together, it's a little bit of a tough lesson because we're just learning a whole bunch of new terms and practicing. So that's okay, we'll still get through it. And to make you feel better, this is a really important topic in grade 12. So it's one of the outcomes that appears in grade 11 and in grade 12. So when you get to grade 12, they expect that you come in knowing how to graph reciprocal functions and then to go on with that. So next year, we'll have an entire unit on rational functions. Your title says rational functions, but technically, we're only doing reciprocal functions in grade 11. That's all that the curriculum guide requires of it. Reciprocal functions is only one specific type of rationals. In grade 12, you'll have an entire unit. We'll graph a whole bunch of different type of rational functions. But in grade 11, you need to know reciprocal functions. If you come into grade 12 knowing that and some of the key terms, that will just make your rational function unit a little bit easier next year in grade 12. Okay, so a whole bunch of new language that we'll start with. Well, not the first one. The first one is reciprocal. We should know what the word reciprocal is, right? So the reciprocal of 2 over 3 is 3 over 2. We all know what reciprocals are. We've been dealing with that for many years. Remember in grade 10 pre-cal, perpendicular lines have negative reciprocal slopes. So we've done some reciprocal work back in grade 10 math. So that's not bad. But now we're applying them to functions. We've never talked about a reciprocal function before. So it's the same idea. If f of x is our starting function, the reciprocal is 1 over. So today we're going to draw the original graph and then draw the reciprocal. Not hard, but just something different. We've never seen this before. But once you do it, it comes up a lot in grade 12, and it actually comes up a lot in calculus. The students that are taking the calculus course, this is going to be their next unit. So you're going to see this a lot in grade 12 and in calculus. Okay, so our formal definition of a rational function is just a function with fractions, right? So officially, it has the form f of x over g of x, where both f and g are polynomial functions. We know what polynomials are. We had that polynomial unit back in grade 10 math. So basically, you have a polynomial on top, a polynomial on the bottom. How do we graph that? Before we can get to our examples, we have some new language to learn. If we were in class, I would say, I already warned you, it's not a tough lesson, but it's confusing, especially first time through. But once you do a couple of these, it gets much better. But yeah, first time through, it'll be fun. We're going to learn some new terms called asymptotes. There's vertical asymptotes, horizontal. There's actually diagonal asymptotes as well, but that doesn't get covered until university. So in grade 11 and 12, we just have to worry about vertical and horizontal asymptotes. Now, if we were in class, I would ask you, what's it like to graph a rational function? You would say, it's a pain in the asymptote. And no, I'm not trying to be funny. Once you've done a few, you're like, oh my gosh, this really is a pain in the asymptote. But hang in there. Like I said, the first few might be a little bit rough, but once you keep practicing, it's the same steps over and over again. You'll get it. Okay, so what is a vertical asymptote? So it's a vertical line, obviously like the name says, vertical asymptote, vertical line. But when we draw it, it cannot be solid. It has to be dashed or dotted. So that's a communication error if you draw it as solid. So it's not solid, so dotted or dashed, and it should have arrowheads to draw a proper vertical asymptote. Now, how do we know where do we draw the vertical asymptotes? Well, they will go through the non-permissible values. We know that. We're experts at non-permissible values. That makes sense. If it's a not allowed value, then when you draw the graph, you can't have a graph drawn in a spot where there's values that aren't allowed. So the graph will never ever cross the vertical asymptotes because that represents our non-permissible values. It makes sense, right? If we can't have that value in the equation, then we can't have that value on our graph. So it should make sense, vertical asymptotes. Here's the fun one, horizontal asymptotes. Not quite so simple. Our definition is actually a calculus term. The value y approaches as x approaches infinity. That's getting to some language about grade 12 and calculus. Now, there's 3 different types of vertical asymptotes. Vertical asymptotes are easy. Just non-permissibles, that's where you draw them. Where do we put the horizontal? Well, that's a little bit different. It depends on what kind of rational function we have. So I'm going to give you the 3 cases. Now, here's a case where I'm going to tell you right now, I'm not teaching you this topic properly. Not that I'm making mistakes, But basically, I'm just going to say these are the rules, memorize them and use them. And that's how we teach them to you in grade 11 and grade 12. Well, why don't we teach you the proper way? Because the proper way, you need to know calculus. So you'd have to know what limits are and use limits and properly define that to show why there's 3 cases. So the students that are taking calculus, they already had their limits test. And on their limits test, they were talking about horizontal, vertical asymptotes as well. But you need to know what a limit is, and that takes an entire unit on its own. So for grade 11 and 12, they tell us, teach you guys about horizontal asymptotes, but don't talk about limits. So it's a little bit tough. So for grade 11, 12, I'm just going to say, here are the rules, memorize them, use them, trust me, and if you want to see why these rules exist, then take calculus. There you go. Okay, so we just want the rules. What are the 3 rules? So we have 2 polynomial functions. A and B represent our leading coefficients. So those are the coefficients in front of the term with the highest degree. A degree just means the highest exponent we have. Now this is the letter N, that's the letter M. It's supposed to be an M, my pen keeps cutting out. Basically the letters don't matter, we're just comparing. If you have a higher degree in the denominator than you do in the numerator, then your horizontal asymptote will always be at y equals 0. What if the numerator and denominator have the same degree, the same highest exponent? Then it's not so easy. You divide the leading coefficients. And the last case, what if your denominator is a lower degree than the top? Then there's no horizontal asymptote. Now, the good part is in grade 11, every single case is this one. Because we're just doing reciprocal functions, we're always going to have case 1. So for our examples, this year, y equals 0 is always our horizontal asymptote. But next year in grade 12, it won't. You're going to have to know all 3 rules and apply. So I just feel like I have to give you the full story in grade 11 so you realize there's 3 options. I just don't want to misrepresent it in grade 11 thinking it's always y equals 0. And then you come to grade 12, you're like, well, what? Where are all these other horizontal asymptotes coming from? So I'm giving you the full story, but this is the only one we need to know this year. And here's the fun part. Can a graph cross a horizontal asymptote? The answer is yes, it technically can at certain parts, right? Vertical asymptotes, you can never cross a graph. Horizontal asymptotes, some parts can't. But again, that's getting into calculus. So that's the full story. So like I said, you see why this is a fun lesson we're getting into. Okay, so we hopefully kind of know what a horizontal and vertical asymptote is. Like I said, we do have diagonal asymptotes, but that's covered in university. Okay, so we have our simple steps. How do we graph that? So step 1, we have to graph the original function. The good news is in grade 11, the original function for us is always going to be a line or a parabola. We're experts on that. Last year, grade 10, we spent a month learning how to draw linear functions, and we spent a month this course together before school suspension drawing quadratic functions. So you should be able to draw any kind of line or parabola at this point. And if you can't, well, now's a good time with your extra time to go back and review how to graph a line and a parabola. We don't care about the method anymore. I showed you several methods in our unit of quadratic functions. So as long as you get your proper shape, the method doesn't really matter. Except, well, this year it's a little bit different, but in grade 12 you won't be allowed graphing calculators. So if you're relying on technology at home this year, you're just going to make it a little bit harder on yourself next year. So try not to always go to Desmos and technology. Try and do it without, because in grade 12 you will not have access to any kind of graphing app or calculator. So step 1, for us this year, the original function will always be a line or parabola. But next year in grade 12, they can give us any shape. So you'll see lots of interesting shapes next year's our starting one. But for us, starting function is a line or a graph. Then step 2, from the original graph, figure out what the x-intercepts are. That's pretty easy. Just look for the x-intercepts off of the graph you drew. And these are going to become the vertical asymptotes of a reciprocal graph. And that makes sense, right? Because that's where the y value is 0. So when you try to divide by 0, we know that you can't divide by 0. That's non-permissible. So the x-intercepts of the original become the vertical asymptotes of the reciprocal. Do you see why it's getting fun? I didn't lie to you. This is a fun lesson. Okay, step C, determine the horizontal asymptote. Like I said, you would have to go through and test the case, compare the degrees in the numerator and denominator. For grade 11, your denominator will always be a higher degree than the numerator. So for us,